Hello everyone, you are all welcome to lecture number 1251, and today's topic is the relative stabilities and conformation of cyclohexane molecule. So here actually the students should understand very clearly these terms like conformation, configuration, because unless it is clear that how the atoms are arranged within the molecule, how molecule is twisted and arranged in this space, and how the electrons are arranged in subshell, whether they are paired or unpaired, only then they can enjoy the stereochemistry of organic molecules and organic compounds. And stereochemistry is very important, which plays important role not only to determine the shape and geometry of the molecule, rather its physical and chemical properties. So first thing is, these terms should be clear to students. One is called configuration. Second term is called configuration. One is I and one is U. And third one is conformation of the molecules. So these three terms are widely used to determine the stereochemistry of organic compounds. So here first one, that is configuration, and second one is configuration. So there is a big meaning of U and I. The only difference in these two is that on top it is configuration, and here it is I and U. But in the case of configuration, means the arrangement of electrons within the subshell. So here it is the arrangement of electrons. Arrangement of electrons in subshell. And here, when I am talking of CONFI, configuration, means here the 3D arrangement of atoms within the molecule. So here it means 3D arrangement of atoms within the molecule. And when I am saying the conformation of the molecule, means it is the arrangement of molecule itself in this space. It is different arrangement of molecules in space. It may be twisted form, chair form, board form, etc. So here now the concept of these three terms are very clear. It should be clear to students that in one case where there is configuration, the arrangement of electrons in subshell. So when we are talking of shell and subshell, again we should have very clear picture that all the atoms, they have shell, K, L, M, and shells, and these shells having the capacity of keeping electron, that is 2, 8, 18, 32, that is in shell. And when we are talking of subshell, means S, P, D, and F, means these subshells, they have the capacity of keeping electron, that is 2, 8, 10, 14, like that. And these subshells, they have compartment of keeping two electrons. Keeping two electrons in one compartment or subshell of electron, and where two electrons can occupy these compartments, and these electrons either they are in this form or they are in this form. So once the electron which is arranged where two of the spins of electrons are in opposite direction, then it is called paired electron. Then it is called paired electron, and once the spin is both electrons on the same side, then it is called unpaired. So two conditions of electrons to be present in this electronic compartment. One condition where both spins are on the same direction, that is called unpaired, and where it is in opposite side, it is called paired, or in other words we call it singlet and triplet state of electron. Now here we have to see which arrangement is stable, because for every molecule we have to go towards its stability. So the one which is paired is stable, and this is unstable. Why it is stable? Because once this, for example, if suppose I have, let us see, you consider that these two are electrons and its spins both are in the same direction, and it is unstable. So how to flip it into opposite direction? This one, by watching, by reciting something, it will not happen unless I bring my hand and finger and hold it and flip it into opposite direction. Now it became paired. So energy is used from this system. So it will be having less energy in order to flip it into opposite direction. So this one is stable because the energy is less. Energy is less. And here it is energy is more. So this is what about configuration, which is very, very important to understand the energy level. And now I am going to show you the images. So here in this image, you can see very clear picture of paired and unpaired electron, and the explanation what I have given over this whiteboard is more simpler form. And here they have shown in SP, D and F how the electrons are arranged, either in the form of paired, that is opposite spin, or in the form of unpaired, that is spin in the same direction. In this image, it is very clearly given on the basis of energy level how these electrons are arranged and their orbital picture, and that is in SP, D orbitals, and according to their arrangement, whether they are in high energy level or low energy level. It is 3D arrangement of atoms within the molecule, that is called, it is configuration, not configuration. So here the different arrangement of atoms within the molecule. So in this image, very clear image is shown about the conformation of cyclohexane, how cyclohexane is twisted either in the form of chair form or in the form of boat form, or half twisted or full twisted, and that condition of the arrangement of molecules within the space in different twisted form is called conformation of the molecule, or we can say SPATIL, special arrangement, that is the arrangement of molecules in the space. So here in this image, the both chair and boat conformation is there, and here they are showing the bond of hydrogens. So the hydrogens, either one is towards axis or other one is towards equatorial. So these cyclohexane molecules, they are having two type of bonding, either towards axis, that is called axial bonding, and the other one which is towards equator, that is we can say not vertical, perpendicular. So one is vertical and one is perpendicular towards equator. Such type of hydrogens are called axial or equatorial hydrogens, and bonding is called axial and equatorial bonding. And these axial and equatorial bonding as well as atoms, they play a very important role in determining the stability of the cyclohexane molecule. So here I have given you the most important two conformations of cyclohexane, that how in space they are twisted in the form of either chair or board. So this is called board conformation of cyclohexane, and this is called chair conformation of cyclohexane, and it is having two type of hydrogen bonding. One is called axial hydrogen bonding, and it is towards equator, vertical. So once it is vertical towards axis, it is called axial, and the other one is called equatorial. Equatorial hydrogen means it is towards equator, horizontal. So once it is horizontal and towards equator, it is called equatorial hydrogen, and the one which is vertical towards axis, it is called axial hydrogen, or any atom. If any atom which is linked to cyclohexane molecule in twisted form, either boat or chair form, if it is vertical, in vertical direction, it will be known as axial group, and if it is towards equator, horizontal, it will be known as equatorial. For example, if suppose there is CS3 in chair form and another chair CS3 is here. So 1, 2, 3. So we will call this substitution 1,3 diaxial dimethyl cyclohexane, because at axial position it is methyl group is attached, and here at axial position again methyl group is attached, and if such type of arrangement is there, that is called 1,3 diaxial position. So even for this there is serious chemistry to discuss the stability of 1,3 diaxial cyclohexane molecule. So that I will be discussing later on. Today I will stop here, and just you have understood all the conformations, configuration, arrangement of atoms, that is in 3D position, then twisted form. And in the next lecture I am going to explain the stability of twisted form of cyclohexane, that is either chair or boat form. So with this I will stop. So with this I will stop. Thank you very much for watching the lecture.